Okay, this last quest, we're going to take electron configurations and use them or relate them to the periodic table. So we're going to see how the periodic table serves as a roadmap for our electron configurations. Have your periodic table ready to go. Remember that rows go horizontally, so let's review that. Rows go horizontally and columns go vertically, okay? And that'll help us do some work here. So first step is write electron configurations for Li, Na, and K. Don't need the arrows, just the configurations. So go ahead and do that now. You pause now and go ahead and write those down. Okay, after once you've written those down, let's take a look at them. And so we're looking at Li, Na, and K, and they are here. Li, Na, and K, so lithium, sodium, and potassium. And the question, and you can compare to your answers. The question is, what is similar about the configurations? And look at the very end. So what's similar? They all end in S1. So what's similar? They all end in S1, right? So now lithium is in row 2, sodium is in row 3, and potassium is in row 4. How do the row numbers affect their configurations? Well, let's look. Lithium's in row 2, sodium's in row 3, potassium's in row 4. So let's look at the periodic table. Lithium's in row 2, sodium in row 3, potassium in row 4. So the rows give us some energy levels, right? So we can say that how do the row numbers affect their configurations? And not the end, but the energy level is same as row. Okay, so we can see that we count down the rows, we can see that. Okay, so now let's write the electron configurations for beryllium, magnesium, and calcium. Pause now and do that. Okay, so now let's look at beryllium, magnesium, and calcium. And there's are the configurations: beryllium, magnesium, and calcium. And what makes them the same? Well, you can see they're both S2. So knowing that, they end in S2. Beryllium is row 2, magnesium is row 3, and calcium is row 4, right? Row 2, row 3, row 4. And if we look at the configurations, we see 2, 3, and 4. So the row numbers, just like the first one, row matches the energy level. So knowing that, elements ending in S1 are in column number. So let's look at the periodic table. If it ends in S1, they're in column number 1. And those ending in S2, which are here, are in column number 2. So we can kind of make a look at the end of the configuration and figure out where they're at in the periodic table. So knowing that, let's see if we can figure out where the last configuration tells us. So if a configuration ends in 5s1, it's rubidium, right? So I count down 1, 2, 3, 4, 5, and it's rubidium. What about if it's 6s2? So I count down 6, 1, 2, 3, 4, 5, 6, and go 1 over. That will be barium. So that would be barium. 7s1, I count down 7, 1, 2, 3, 4, 5, 6, 7, and 7, 1 would be francium, Fr. So now I'm starting to see how this is all starting to fit together, hopefully, okay? So let's look at some other configurations. Boron, aluminum, and Ga, gallium, write those down. And also nitrogen, phosphorus, and arsenic. Pause and do that now. Okay, so once we look at those, let's bring those up. Here they all are. Here's boron, aluminum, and gallium. And then here's nitrogen, phosphorus, and arsenic. And you can see some things that might be common with those. And their similarities are boron, aluminum, and gallium all end in P1 so there's boron, aluminum, and gallium all end in P1 with a number in front, 2, 3, and 4, matching 2, 3, and 4 where they're at. And then I look at nitrogen, phosphorus, and arsenic, nitrogen, phosphorus, and arsenic, and they end in P3. So this is all ending in P3, and this is energy level 2, 3, and 4. And if we look, 2, 3, and 4. So you can see where, again, in the same column, we got some commonalities there, right? So now, and make sure you write those notes down. Elements ending in P1 are in column number, so P1 is here. I call this column 13. Some people call it 3A. I'm going to call it 13, but I'm going to put both answers down. 13/3A. P3 is where nitrogen's at, and that's 15/5A. Right? 15/5A. 15/5A. And P2, we can make the assumption that if this is P1 and this is P3, P2 has to be right here. So 14/4A. Okay. So now let's take a look and see if we can figure things out. So 3P4 is sulfur. So let's find sulfur. Let's find 3. I count down 3. Then I go to the P's and I go 4 over 1, 2, 3, 4. There's sulfur. All right. So now they're saying we want to look at here 5P6. So I count down 5. 1, 2, 3, 4, 5. I go over to the P's and I count 6. 1, 2, 3, 4, 5, 6. 5P6 is xenon. So that would be one of our noble gases, Xe. 6P5. Count down 6. 1, 2, 3, 4, 5, 6. Go to my P's and I count 5. 1, 2, 3, 4, 5. And that's astatine, AT. AT. All right, some more configurations. TI, ZR, HF, and their similarities. So let's look at those first. All right, TI, ZR, and HF. So type those in or write those down now. Pause and do it. Okay, so now here's TI, ZR, and HF. And what do we notice? Look, D2, D2, D2. And they have energy level 3, 4, and 5. So let's look at TI on the periodic table. TI is here. Now it's 1, 2, 3, 4 rows down, so it doesn't really match the energy levels, but D1, D2, zirconium, D1, D2, hafnium, D1, D2. This is what we're looking at right here, okay? So we can see those all in D2. And then CR, MO, and W, again, pause and write those down now. All right, so now CR, MO, and W, CR, MO, and W, again, 3, 4, and 5 really don't match the rows, but 4, 4, and 4 are where they're at. So let's go CR, MO, and W. Again, CR is 4 down, MO, and W, but they're all here, and they're all with D4. These are D2, these are D4, which would make these probably D3, right? So our Ds we can see there. So D2 are in column number 4, right? And it's called 4B, but I think we can just call it column 4. D4 are in 1, 2, 3, or the chromium, right? And that is column 6. So D3 should be column 5, and that's fair. D7, so let's say this is D4, 5, 6, 7 would be column 9. Okay, so we're going to say that's column 9. So elements end in 3s are in the third row. Also from questions 9 through 12 is clear that the element that ends in 3p is in the third row. However, there's an element that ends in 3d is in the fourth row instead of third row. Explanation for this? That's just the way the energy levels work out. So the note I would make is this. If I'm talking about the Ds, okay, so this is the Ds in this little block here. The Ds start at level 3, even though this is fourth level for S and P. The Ds start at 3. And we know that because after 4s is 3d. That's just the order of the energies. So it's not a perfect way to use the periodic table, but it can. So it's the order of the energies. So let's see if we can figure some of these out. So 4d3. All right, let's look at 4D3 and see if we can figure this out. So if D start at 3, 4D would be down here, this row. All right, and then I go 4D3, 1, 2, 3, and B, niobium. All right. Now we look at this next one here, 5D8. All right, 5D8. So this is 3, 4, 5D. 1, 2, 3, 4, 5, 6, 7, 8. Platinum, PT. So this would be PT. 3D6, our D start at 3. So we start at 3 and we count 6. 1, 2, 3, 4, 5, 6. And that would be iron, Fe. So there are 3 major divisions of the periodic table, the S, D, and P block. Where are these blocks and elements located? Give the column number of their locations. F block, but we won't talk about F block just yet. Okay, so the S block is columns 1 and 2, right? So we call the S block columns 1 through 2. The D block columns start here at column 3 and go all the way to column 12. So it's 3 through 12. And then our P block columns are 13 through 18. All right, 13 through 18. And that's how we can look at our columns. Now, real quick, S holds a max of 2 electrons. How many columns? 2. D holds a max of 10 electrons. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. P holds a max of 6 electrons. 1, 2, 3, 4, 5, 6. Now our F's are down here. Okay, so on our periodic table that we have, 57 should be here, 89 should be here. So when we count these, would be our F block, and that would be 14 because the F block can hold a max of 14 electrons. So we can count the number of electrons max by using the periodic table. All right. So electron configurations can be shortened using a special group of elements called the noble gases. They are found in the column furthest to the right of the periodic table: helium, neon, argon, krypton, xenon, and radon. So when we look at the periodic table over here, those are the noble gases, right? And we talked about that earlier. These gases are very non-reactive. All the noble gases have electron configurations that end in P6. And again, we know that they're in the P block, and that's P1, P2, P3, P4, P5, P6. So they all end in P6. So look at krypton's electron configuration, 4p6. It goes 1, 2, 3, 4 down, and there's krypton, 4p6, right? Now notice that strontium's electron configuration is the same as krypton's, except that strontium has 38 electrons instead of 36. Strontium's electron configurations goes all the way to 4p6, but then it adds 5s2. So strontium is here, right? 4p6, and then this is 1, 2, 3, 4, 5, s2. So strontium shows up there. Therefore, strontium's electron configuration can be abbreviated. You take krypton and put it in parentheses and put 5s2. This notation means that strontium has all of krypton's electrons plus 2 more in the 5s sublevel. Let's look at iodine. Instead of writing everything out for iodine, we can do the following steps. So we go backward from iodine in the periodic table. So there's iodine, and we go backwards. And we find that krypton is the nearest noble gas backwards, right? Take note of where krypton's electron configuration ends. It ends at 4p6, and iodine has 17 more electrons. So then we write down everything that comes up after that. So 4p6, 5s2, and this is 4d, so 4d10, and then we got 5p5, and that would take us to iodine, right? 1, 2, 3, 4, 5, and we see that iodine gets us there. I can't find my document. There it is, to 5p5. So any of the noble gases can be used for abbreviations. There are a few more examples. Iron is argon with 4s2, 3d6, and so forth. And you can look those up as you go. But let's check them out here really fast. I'm going to change the thing around here. Okay, so let's go. Iron is argon, so it's argon, and then I go 4s2, and then 3d, 1, 2, 3, 4, 5, 6. and that's iron. Cesium is xenon plus 1, which is 1, 2, 3, 4, 5, 6s1. And then phosphorus is neon, and I go 3s2 and then 3p3, which is what we see here. All right, those are examples. So let's do a couple here and see. So we want to go Ru, ruthenium, and I have those up here. So ruthenium, and the first thing I want to do is make a bracket, right? Make a bracket, and I want to see, okay, so where's ruthenium? Ruthenium, 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 ruthenium. Where's it at on the periodic table? Right here, right, number 44. So I go backwards, and it takes me to 37, which means krypton. So ruthenium is going to be krypton, Kr. And then I just pick up after krypton. So krypton, and then I go here, and this is 1, 2, 3, 4, 5s2. 5s2. And then I can go 1, 2, 3, 4, 5, 6, 4d6. And that's the abbreviated of ruthenium. So let's go to arsenic, and let's find that in the periodic table. Arsenic is As, and it's right here. I go backwards from arsenic, and it takes me to argon. So argon is what I put here. So I go Ar, and then I go from Ar up. So I go to Ar to potassium. Potassium is at 1, 2, 3, 4, 4s2. And I keep going, 4s2, 3d, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 3d10. And then I go to arsenic, which is 4p1, 2, 3, 4p3. And the last one on the list, tellurium, Te. Tellurium, let's find Te. It's right here, right? And it's number 52. So I work backwards, and it takes me to krypton. So tellurium is krypton, so Kr. And after Kr should be 5s, 1, 2, 3, 4, 5s, so 5s2, 5s2, and then I keep counting. 1, 2, I got my 4d, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 4d10, D10, and then after my 4D should be 1, 2, 3, 4, so it's 5p4. 5p4, and that's the abbreviated configuration for tellurium. So the abbreviated configurations are an easy way to do it. You should definitely be able to write out the whole configuration, but there'll be times when you can use abbreviated, and as you get better, abbreviated will be the way to go. A lot here, okay? Let's see if you can do configurations now.